Let's continue with our OWASP update. So before we get started, let's just announce our, well, probably one of the most important thing that's been happening this year with OWASP is that OWASP is turning 20 this year. So OWASP has been founded in 2001. And as part of the celebration, OWASP is going to celebrate its anniversary with a live 24-hour virtual event. And that's going to be running from 24th to September 25th. If you remember maybe the DevOps Days, it's a similar concept. So this is going to be sort of like the DevOps Days version of OWASP itself. The great thing about this conference is that it's going to be completely free. So if you are interested in learning all the things about application security, cloud native security, penetration testing, or even malware analysis, definitely check out the OWASP 20th anniversary event and register today at 20th anniversary.owasp.org. Also, maybe if you don't have 24 hours of your time to spend and you want to have something more packed, and especially if you're interested in cloud native security, we highly recommend checking out the OWASP Lightning Conference. The next one is going to be running on September the 28th, and it's going to be all around the future of security cloud native, and it's featuring Carolyn Wong. So it sounds also like a really interesting event. It's usually running around 90 minutes. And so you don't have to sit the whole day in front of your laptop. However, same as with the 20th anniversary, it's going to be completely free. So check out today's lightning.owasp.org and don't miss that, because I think it's a really exciting opportunity. And also, if you're interested in speaking yourself, just get in touch with the OWASP Foundation, and maybe some of your talk will be hosted in the upcoming Lightning Conference. Great. Now let's highlight our speakers for today. Rory McCune, first of all, will share his insights on container orchestration concepts and also talk about what they mean for security. Rory will examine some of the pitfalls, both in Docker and Kubernetes environment, and then mention why they're essentially remote code execution as a service. I found Rory McCune very interesting, his talks about container orchestration security, because he's been for the community quite a while. And to be honest, when I seen his first talk, it was quite an eye-opener for me in learning about the fundamental concepts. And I'm really glad that he has been willing to share his knowledge and experience for tonight. After that, we are delighted to have Kyle Cucci talking about malware analysis to drive threat hunting and detection engineering. As part of that, Kyle will demonstrate how malware analysis can enhance the usage of frameworks like MITRE ATT&CK and really provide valuable insights on present threats for your organization. So really interested to see how you can actually use malware analysis to improve your threat detection rules. So really looking forward for this. First of all, let's start with Rory. Rory has over 20 years of IT experience and is also the author, or one of the main authors of the CIS Benchmarks for Docker and Kubernetes. He is also a very active member of the container security community, where he has delivered numerous presentations across the US, including on BlackHat US. However, these days, Rory likes to spend his time on working on cloud native security as a cloud native security advocate for Aqua. When he's not working, Rory can be generally found out walking, enjoying the scenery of the Scottish Highlands. Rory, are you ready to talk?
Indeed I am. Hopefully everyone can hear me okay.
Yes, we can hear you.
Awesome, thank you. Great stuff. I will get started.
Yep.
Right. Good evening, everyone, and hopefully this will be an interesting talk for you around container orchestration and container security. Let me just share my screen. That one should be the right one. Okay, so hopefully you should have my slides up there. Right, so what we're going to talk about container orchestration and what it means for security. I've been doing kind of container security stuff for around 5 years. And in that, the marketplace and the kind of the prevalence of it has kind of changed massively from being, kind of the few early adopters who are kind of very, getting started with Docker and using containers, to being now where we see pretty much every market segment making fairly heavy use of containers and Kubernetes and Docker. So what we're going to talk a little bit about is how they work, and then talk about the security of them as well. Very brief about me. So as Dan mentioned, so my background essentially is IT security. I've been in IT information security, primarily in the financial services world, also in the Big Four for about the last 20 years. Most of the time, being a pen tester, and over the last 5 years, moving towards kind of Docker and Kubernetes. I'm my OWASP involvement. I ran the OWASP Scotland chapter back about 10, 12 years ago now. And now I'm a cloud native security advocate for Aqua, which means basically my job is trying to help people learn more about cloud native security. I don't do the product side at all. We won't be talking about any commercial stuff at all today. And as mentioned, one of the things I do around cloud native security is the CIS benchmarks for Docker and Kubernetes. Because one of the things I realized when I got started in kind of container security was there wasn't a lot of material then. It's got a lot better now. So kind of helping working on those. And if you're very interested in container security, you can join the CIS benchmarks pretty easily. You just go to the website and sign up to help contribute to benchmarks. And if it's something you're interested in doing, they're always looking for people to help out. And one of the advantages of kind of doing everything in the cloud and doing cloud native is that you can live wherever you like. So this is where I stay. This is Loch Goilhead in the Scottish Highlands, just west of Loch Lomond. And as you can see, it looks very nice when it's not raining. However, if you know the west of Scotland at all, you would know that's not that common. It's usually pretty wet out here. But as you can see, very pretty when it's not. So let's get started and talk a bit about containers. We'll start off with the fact that containers aren't new. This is the first thing I think that's important to get used to is containerization is not a new thing. And if you've been in IT a long time, you probably kind of thought, well, hang on, this doesn't sound really all that new. I'm sure we've done things like this before. It got started, 1979 was the first time that anything vaguely related to containers probably got started. It was a chroot system called in Unix. And then around 2000, various operating systems, Unix-like operating systems, got something which worked like containers. FreeBSD jails, Linux vServer, Solaris zones. But it wasn't really until 2013 that I think it really started to take off and get really very popular indeed. And that was with the rise of Docker. One thing to mention actually, just as I go while I think about it, if anyone's got any questions as I go along, please feel free to put them in chat. I'll try and keep my eye on the chat. And I'm happy to try and answer any questions as we go, or we can pick up at the end as well. So containers are not new. They've been around a while, but they are getting quite popular. This is from the 2020 Stack Overflow developer survey. So every year Stack Overflow do a survey and they ask developers questions about what they do, how they develop. And this question that we're being asked here was, what platforms do you use? Now, unsurprisingly, Linux and Windows came first and second, but perhaps surprisingly, Docker is third. And that's the second year that Docker has been in the top 3 platforms. So it's more popular than AWS, it's more popular than any of the other clouds or macOS or Android or iOS is Docker. So we can say that this is very popular and a lot of people are using it. And I think that's borne out by, I think if you go to almost any GitHub repository these days and look at how you install, there's probably going to be a Docker option in there somehow. So why are they getting popular though? We know they're getting popular, but why is that? I've got a couple of ideas. I'm sure other people got views on it as well. The first reason I think containers are getting very popular is money. If you look at the kind of on the left here, I've got kind of the traditional way that you might deploy an application on a virtual machine or on a physical server. Typically, people would deploy one application per machine. Now, if you're running in something like EC2 on Amazon, you pay per hour your virtual machine is running, whether it's 1% utilized or 100% utilized, you pay the same amount of money. So if I can get more applications running on the same virtual machine, then I can save money effectively. And that's what containers let you do. Effectively, containers will let you run many applications on a single virtual machine or a single physical server at the same time with a reasonable level of isolation. And we'll talk about, all right, when I say reasonable, what do I mean by reasonable? So that's the first reason. Essentially, companies can save money. And that's why a lot of, when I see kind of people going to containerization or going to cloud native, part of it is driven by trying to get your cloud bill down because you can deploy more applications to the same number of VMs. But why Docker then? Right. So I said there's lots of technologies that do something similar to Docker, but why is Docker specifically the one that gets popular? And for me, it's simplicity. It's the ease of use that Docker brings. that really got people going, got people excited about it. And this is a good example. Docker run -d nginx will run up an instance of the nginx web server, and it will work pretty much the same if you run it on your laptop, if you run it on a production server, if you run it on various clouds. You can run the exact same command effectively using the exact same image, and it will have the same outcome. Getting away from the old problem of, well, it ran right on my laptop, why doesn't it run here? And you can do that with any one of the 8 million images that are on Docker Hub. I actually was updating my slides for this yesterday, and I had 7 million on there, and I noticed that in literally the last month, for when I last ran this talk, it's gone up over 8 million. A first point to make, and it's not, I won't dwell too heavily on it at the moment, is a good thing to know about Docker Hub, which is where most people probably get their container images, is of those 8 million images, there's probably a couple of hundred that are in any way curated, or any way reviewed for malware, or any way reviewed for being up to date. Outside of those, the official images, and any ones that are kind of like sponsored images, which Docker has, there is no curation on Docker Hub whatsoever. There's no guarantee that what you are getting is what it says it is, and there's no guarantee that what you're getting has been patched in the last 5 years. Indeed, there are plenty of those 8 million images that have never been patched. So it's a good point. First thing to watch out for if you are using containers is you know, caveat emptor or caveat downloader is watch what you download, because Docker don't actually do that much curation. So, but simplicity, I think, is that was what won. That's why people went to Docker. It was very easy to use. It's easy to get started with, and it works really well. But there is a problem with containers, especially if you're a security person, maybe you're in InfoSec, you're in IT security, containers isn't your day job, but you have to now think about how to secure containers, is the sheer volume of terminology that comes with cloud native and containers. Every time you turn around, there is a new term that's been coined, or someone's using, you know, some new word to describe something. You have to go and look up what it is. I mean, this is just a word cloud of some of the things you get with Kubernetes. And frankly, there's a lot more to it than that. But it can be a bit daunting. So what I wanted to do with this talk was break down a little bit what containers actually are, and try and show that in reality, at a basic level anyway, they're not that complicated. What they're doing can be quite easily understood using existing technology. You don't have to, you know, necessarily know all the buzzwords to know what's going on. So to do that, let's talk about what a Linux container actually is. So if I do Docker run, and we'll do that, I've got a demo coming up in a second, I'll actually do that. What am I actually doing? Well, the first thing to know, and I mentioned this point because a lot of articles you might read might describe containers as lightweight virtual machines. They're not, usually. There are some ways of running containers that do use virtual machines, but we're talking about standard Docker containers. They're not virtual machines. What they are is Linux processes. So if you use Linux and you get a process list, a container is just a process. And what Docker does is it essentially uses existing Linux functionality, so things that were already part of Linux. It didn't invent, I don't think it invented anything. They basically just reused a lot of existing Linux functionality and packaged it up in a kind of easy to use format. To get the isolation that they've got, so the fact that when you run a Docker container, you can't automatically get access to the host machine, they used a number of Linux features. There's namespaces, and what a Linux namespace does is it gives an application process a restricted review of some resource that the operating system has. So that could be the file system, it could be the network stack, it could be the process list. There's different namespaces for different resources in Linux. And what Docker does essentially is automatically apply a set of namespaces. So when you run your container, you can only see certain resources. Then it uses capabilities, which are a way of breaking up the root right in Linux. So it's not like all or nothing. You can use capabilities to say, I don't want to give you all of root's power. I'm going to give you a little bit of it. And it uses those. It uses C groups, and C groups are designed to restrict what resources it can get access to. Because if you're running 10 containers on a host, you don't want one of the containers to chew all the CPU. So you need to apply C groups to stop that happening. And then it's got some other additional layers. If you're running on a Debian base, it'll use AppArmor. If you're running on a Red Hat base, it'll use SE Linux or SUSE. And then it also uses seccomp. And what they're doing here, the reason they've kind of got these AppArmor and seccomp layers is they're trying to create a sandbox. So Docker is not, I would not call Docker a security sandbox. It's not designed to be a sandbox, but what they're trying to do is create something that works a bit like a sandbox. So it actually isolates a process from the rest of the machine. But it was never designed to be like what I would call a security sandbox in the sense that was intention when they launched it. But that's the kind of effect. So in the let's try and see if we can do some demos and see if they're going to work tonight. Hopefully now you can see my terminal screen.
Yes.
So what I'm going to do here is I've got a machine that's got Docker running on it. I'm on a Linux host. Hopefully that's big enough. I'll make it a bit bigger so everyone can hopefully see. If I do psef and I grep for nginx, at the moment, right, there's no nginx processes running on this machine, right? It's just the grep command that come back. If I now do docker run nginx, that's just a Docker command to run an instance of nginx and give it a name of web server. And then I now do that ps command again. What do I get back? That. As far as the host is concerned, I've just launched nginx. I've got a new nginx process running. And if you want to interact with or secure Docker containers, they are literally processes. These are all, the Docker container is just these processes here. And the fun thing you can do is you can actually interact with them without using Docker. So just to demonstrate that, what I'll do is I'll use a command called docker exec, which just executes a command inside a container. And what we're going to do is just create a new file. So I'll create a new file. So that created a file inside my container. Let's say I want to look at the file system of that container without using Docker. I can do that. If I do sudo ls proc, and then the process ID I want is here, which is 5618. That is the root file system, the root file system of the container, right? So as you can see, what is it? If you don't know proc, if you've not done that much Linux, so proc essentially is a virtual file system in Linux. And what it does is it has a whole lot of information about the running system. One of the things it does is for each process running on the host, you can see the root file system of that process. Now, usually if you've got no namespaces, that's just the same as the root file system of the host. But in the case of Docker, it's not. So this is the root file system of my container. And you can see that because there's my new file. There's the new file I set up. So that's just to kind of prove the concept that Docker containers are literally just processes. There's no magic there, right? It's just launching a process and applying some constraints to it. So if you think about securing it and you're thinking about how you secure Docker containers already, you can say, well, if I know about Linux, I know about Docker. So that's. So when I did that, when I launched that container, I used a container image, right? So nginx is the image that was used to launch the container. So what is a container image? And as I said, actually that screenshot's all about 3 weeks old, so there's only 7.9 million images there. A container essentially is just a tarball. So when someone says Docker image, what they mean is tarball with some files in it. That's literally it. Or actually it's a set of tarballs, and I'll show you that in just a second. Essentially a Docker image is just a tarball. So if you want to look inside it, you can download it and extract it just like a tarball. If you want to do forensics on a running container, you can turn it into a tarball and then just extract it and look at the contents of the file system as though it was that container. Again, it's just Linux. So let's demonstrate. So what we can do is, let's make a directory called nginx. And then go in there. And then what we're going to do is we're going to do docker save nginx. What we're going to do is just create this tarball. So let's get docker latest. So nginx save.tar. And that command just essentially gives me a tarball that is the container image I've used. Then what we can do is we can say tar -xvf nginx save, and it was, what's the command for that one? Handy flag I learned about tar is you can do this to make it create a directory for you. I didn't know that until I looked this up recently. So what that does is that's given me a directory called nginx save, which is the name of my image. And that is a Docker image, right? What the kind of all the nasty SHA hashes are is each layer of the Docker image gets its own little directory. And then it has some JSON, which is just the metadata for that image. So if you ever want to analyze a Docker image or in any way manipulate it or review it, You can do that just literally with tar and then extracting it. And if I do tree, you can see how it looks. Essentially, each layer is a directory. Inside that are the files that came with that layer, which are one or more files. And then this particular image has got 6 layers in it. There are more or less depending on how the image was created. So that's what it looks like if you kind of get an image. You can also do this with a running container. So if I create a running container, I'll just run a new container. So all I'm doing here is I'm just running, again, another instance of Nginx. I'm going to give it a name. And then I can do Docker export. And then create. So this is slightly different. What I'm doing here is running this export command. And you can do this on a running container. So if you want to, for example, do forensics on a container, you can just do Docker export. And it will turn the running container, so the image plus any changes that were made to it, into a tarball. And then I can tar f nginx export. Ooh. Okay. What that's done is that's given me the entire file system. So instead of having all the kind of hashes and all the different layers, that literally just flattens the file system. So that's the Nginx image, except that's it as a set of files. And if I do tree, that's literally all the files that come inside that image. So if you ever, again, want to analyze a container or do anything else with it, as you can see, it's literally just a tarball. All of it's Linux. Everything Docker does is Linux, pretty much. So that's what an image is, right? Images are just tarballs. So what is Docker? So we know that containers are processes, and we know that images are tarballs. What is Docker then? Well, Docker essentially is a client that talks to an HTTP API. So if you're used to web app security, Docker is a REST API. You can talk to Docker, the Docker engine, using curl if you want to. So basically, you have a Docker client, which is a Golang binary, which talks to an HTTP API, which then talks to another HTTP API, which is Docker Hub, which again is the REST API, so any web services style stuff works fine there, which pulls down a tarball, puts the tarball onto a machine, and creates a process from the tarball. That is Docker. That's what Docker does. It's pretty straightforward. Not too bad anyway. Just demonstrate. I can kind of show you what I mean by that. And I am going to, I'm just going to run a command here, socat. So if you've not used socat, essentially you can use socat for talking to Docker sockets or indeed any other Unix socket. And I'm just going to create a temporary socket file just so I can show you what Docker actually looks like when you run a command. So I'm just going to leave that there. And then in this window here, I'll just do Docker images. So I'm just going to point Docker at my new temporary socket I just created and say, show me the images. So it just shows you all the images I've got downloaded onto this machine. But back here, we can see exactly what actually happened. And what you can see is it's literally just talking to a REST API. So it first off pings it, and it's got a user agent, which is recognizable. So it tells you what version of the client's running. And then it will come back and respond and say, yes, I'm alive. And then it says, get v141, which is the API version, images JSON. So give me a list of the images in JSON format. And then the server comes back and says, here are all your images. So literally Docker is just a REST API. That's all there is to it. A REST API that pulls down tarballs and creates processes. So hopefully now that's kind of like a basics of what Docker is. What about security in Docker? So Docker is, from a security perspective, command execution as a service, literally. That's by design. Docker has what I call a flexible security model. It was designed by developers for developers. As a result, the focus is on making it easy to use. Right? That's the reason Docker is so successful, is because it's very easy to use. As a result, it has quite a flexible security model. It uses all these different Linux features to create a kind of sandbox, but it allows you to remove it all. So if you can run Docker commands, then you can essentially pretty much always get to be root on a host. So anytime you see, if you're analyzing a system and people are giving Docker access to someone, you should just think of them when you're threat modeling that as this person has got root. This person is root on the host. We can demonstrate this with, this is my favorite Docker command. Now I know it's probably a bit sad to have a favorite Docker command, but this is mine. And this is called the most pointless Docker command ever. It's called that because that was the blog of the person who wrote it. A guy called Ian Meal about 5-6 years ago now wrote that this was the most pointless Docker command you could use. And we can demonstrate what it does. And before I run it, I'll kind of walk through it very briefly. So what we're doing here is we're going to say docker run, so run a new container, -ti, which means give me a shell inside the container effectively, -- privileged. If you're doing container security, watch out for this flag. This means remove all the security. So anytime you see an application you're installing in a cluster or somebody wants to run a Docker container, if it says -- privileged, that means just remove the security away. Then this says remove the namespaces. So this is basically give me access to the host's resources. This one then says mount the host's file system inside the container at /host. Use the busybox image and do chroot to host. Now, if you've done much Docker, you probably know what's going to happen when I hit enter. If you notice right now, I'm the Rory M user on this host, CSF. When I hit enter, I'm now the root user on this host. Right? It's that simple. Now, that isn't a clever hack or leet or anything. That is literally by design. That's how Docker is meant to work. If you have access to Docker, you are meant to be able to do this. Once you've done this, just to demonstrate, we are fully root. We are the proper root user. You know, there's no restrictions. I can do anything I want. I am root. So that's a kind of, when I talk about Docker security, that's one of the important points to get across is this is by design. This isn't anything, that's unusual. And when you're reviewing Docker or looking at how container systems work, this is worth taking that into account. But a useful command to know. They call it the most pointless Docker command. In my opinion, it's the most useful Docker command. So that was Docker, and that was a fairly kind of like rapid run through Docker. But just to give you a picture of the fact that what Docker does is literally just Linux. So what's Kubernetes? So the thing about Docker is that Docker essentially is a single host solution. It's designed to run containers on a single machine. They do have an orchestration solution called Swarm, but to be honest, I don't see it used that often. Pretty much when people want to run containers across a large number of machines, the most common way of doing that at the moment is to use Kubernetes. And this is a kind of a basic diagram. There's lots and lots of different ways of using Kubernetes and lots of different ways that it's kind of like architected and designed. This is the most basic option. So just kind of give you a picture of how it's put together. Essentially, if you look down here in the bottom right-hand corner, what we've got here is the container engine. Now that could be Docker. So traditionally, it was always Docker. In fact, it had to be Docker. These days, you might see other projects which work similarly. So if you're using Red Hat things, you might see a thing called Cryo, which runs the same kind of way, or a project called Containerd, which is actually used by Docker as well. But a lot of more modern clusters will just use Containerd directly now. They won't use Docker. Then it's managed by a thing called the kubelet. So essentially, the kubelet tells Docker what to do. And it runs on each worker node. And then on the control plane nodes, the main thing we have to worry about, the main thing we talk to is this thing here, which is the API server. And the API server is a REST API. So it's another thing to talk about. If we're talking about web security, and this being OWASP, worth doing. Pretty much all these things are REST APIs. They all just, you can talk HTTP to them and use curl. So if you're security reviewing them, or you are looking to defend them, things that defend REST APIs can be used with Kubernetes. So this is a REST API. The kubelet is a REST API, not a very well-documented one, but it is a REST API. And essentially, the way this works is that you as a user will talk to the API server. You'll say, hey, Mr. API server, I want to create 20 instances of my Nginx. I'm a big company. I want 20 web servers. It will then talk to 20 worker nodes, or maybe some number of worker nodes, and say to the kubelet, hey, I want you to launch 1 or 2 of these web servers on this node. The kubelet will talk to Docker, and it'll say, hey, Docker, go and get a copy of the Nginx image, and please run up 1 or 2 or 3, however many it is that you need to have. There's some extra components around there. there's a thing called etcd, which is the database that Kubernetes uses to store all its information. The API server doesn't have a data store itself. It uses an external project called etcd. That's a key value store. It doesn't, like, you can use HTTP with it, but it usually generally uses gRPC, so it's a bit of a pain to talk to sometimes. But essentially, it's a fairly straightforward, simple database. And then there's some other components that it uses. We won't go into too much detail of those. The ones in red are the ones from a security standpoint you really need to worry about. So anyone can talk to the kubelet. They can take control of nodes. Anyone who can get control of the API server can get control of the whole cluster. And anyone who can talk to etcd can pull all the data of the cluster, because it's literally just in one place. So those are kind of the 3 ones. If you're talking about security architecture, those are the ones you typically need to focus on. So if Docker is command execution as a service, then Kubernetes is distributed remote command execution as a service by design, essentially because it orchestrates Docker, right? So literally, when you tell Kubernetes to go do something, what it's doing is telling a set of Docker engines or containerd or something similar to go and do the same thing. So the same challenge applies as if you've got Docker. So let's demonstrate that. I'll need a different host for this one. So not that host at all. Okay. I have got a Kubernetes cluster here, which is working good. And what I'm going to do is I'm going to create a manifest in this. So what we'll do is, the way you do this with Kubernetes is you basically generally say, create -f. You just really give it YAML, which stands for yet another markup language if you've not come across it. And I'm going to create a pod in my cluster from a thing called node root. So while that's creating, I'll show you what node root looks like. So node root looks like this. This is a fairly standard Kubernetes manifest. They're all written in YAML, so white space is significant. And if you're writing manifests and they don't work, it's almost inevitably an indentation problem. But what this is, this creates a pod, which basically, for the purposes of this demo, think of it as a container. But you can see here that in my pod specification, I'm asking for things like the host network and host PID, which is the same as those flags I used before. And then also you can see down here, I'm asking for privileged. So again, we can see danger, danger. If you see privileged inside a Kubernetes manifest, that means turn off all the security. So that's the manifest I just created inside my cluster. And hopefully while I was doing that, it's now running. So it's now running inside, there it is there. So now if I do kubectl exec, and we're going to exec IT, again, the same as the Docker command, we use -it to get a shell. We give it the name of the pod, and then we're going to run this command chroot host. And you can see right now I'm currently on a machine called sapling. That's where I'm running this command from. When I hit enter, I'm now root on the cluster control plane node, right? So this is by design again. If you don't put any additional security controls on a Kubernetes cluster, anyone who can create pods in your cluster can do this. And this is the full root user. These are all the things like the API server. These are all the main components. Also, if you can get access to this, you can go into here. Kubernetes makes extensive use of PKI for security, so it uses a lot of client certificate security. Here you'll see there is a file called c8.key. That is a certificate authority private key. It's not password protected. Anyone who can get read access to that file gets a certificate authority private key, which means they can create things like their own user accounts. So that's generally pretty bad. On an unmanaged cluster, so a cluster you'd install on premises, this is pretty much always possible unless there are additional security controls. And again, that's kind of by design. It's remote command execution by design. So I'll just kind of show that that's how that works. Talk a little bit about securing now. Talk about, I've said that's how Kubernetes works and how it's essentially secured or not secured by design. Talking about how to secure these things, so things you might want to think about if you've got an environment where either you are tasked with securing Docker or you're tasked with securing Kubernetes, which we will see more and more commonly, I think. For securing Docker, Docker access is root. That's the best way to think about it. If you're giving someone, there's the odd project I've seen that have tried to put authorization in front of Docker, but it's not common. By out of the box, Docker access is always root. The main thing, probably for container for Docker security, is ensuring the images are maintained and updated. Like I said, on Docker Hub, there are a vast number of images. A huge number of them are no longer maintained. Worth noting that even a couple of the official images, and I actually need to do a bit more research on this, but I realized this fairly recently, some of the official images are not maintained either. The only way you can find that out is by going onto Docker Hub with a web browser and actually looking at the page for that image, and it'll generally say like deprecated, not maintained, and they'll tell you to go somewhere else. But it's not super obvious from the command line. If you just go Docker pull something, it won't tell you this isn't maintained anymore. By default, Docker containers always run as root. So inside the container, you're always the root user. Now you are constrained a bit, but typically the best recommendation if you're designing systems to run in containers is design your containers not to run as the root user. You want to run as any other user, not root, because it does make various CVEs easier to exploit. There's been quite a few issues now that you had to be root inside the container to exploit, so definitely worth that as kind of a first step. Be careful giving access to host resources. So if you let people mount file systems, they can just mount the root file system off the host, so mount /etc inside the container and then get access. And if you're the root user, you can do things like read shadow or any other technique that gives you root access. For tooling, there's two ones I'd mention as being good open source places to start. There's a lot of tools now, either commercial or open source. Two that I used a lot in my previous life and still use to an extent now. Docker Bench will review a Docker host against the CIS benchmark. So essentially it will check all the things that are in the CIS benchmark and give you kind of an easy readout of things that pass and fail. It's not perfect, but if you're a pen tester, it's a good place to start. Trivy, there are quite a few container scanning engines for vulnerability scanning images. Trivy is Aqua's one. It's an purely open source project, and that will do things like review images. It will also actually review Docker files now as well. Just literally added that last week. You also can review Docker files as well, and Kubernetes manifests actually. So those are some good tools to look at for that. For securing Kubernetes, a lot of it is about restricting access to that API server. So Kubernetes authorizations model is moderately complicated, and it's kind of easy to make mistakes with it. My advice typically is if you're trying to create a secure Kubernetes environment, try and restrict who can create things inside your cluster. So if you can force everyone to go through like a CI/CD pipeline and don't give developers direct access to the API server, that's definitely a win. One of the problems with a lot of cloud managed Kubernetes is they will put the API server on the internet by default and make it visible. So you're one vulnerability away from someone, essentially getting distributed remote command execution as a service in your environment. And I think GKE have gone off that by default now, but a lot of the cloud providers do still do it by default. So there's quite a lot. I think there's well north of 100,000 clusters on the internet. So it is worth knowing that that's kind of a first point of call. If you are giving people access to Kubernetes, RBAC, this is the role-based access control, is how they do most of their authorization. I said it is a bit complex to get right, but it's really important that you lock down what people can do. One thing we've seen with a lot of third-party products that install in Kubernetes is they'll request too many rights. So they'll request cluster admin when they don't need it. So always worth looking for that and making sure that they're actually locking it down. Network policy. So by default, there's a big flat network in every Kubernetes cluster. There's no restrictions on what can talk to what. Network policy essentially allows you to apply like network ACLs. So like kind of a standard firewall style ACL to your workloads to stop things from talking to each other. And then if you want to stop people doing what I did in the demo, which you should, and just like giving it one manifest and getting root, it used to be used a thing called pod security policies, which was a feature of Kubernetes, but that's being deprecated. It's been deprecated now, and it's going to be removed in a couple of versions' time. So now you need a third-party product, essentially. From an open source perspective, there is Oppa, Kyverno, and several others. Oppa and Kyverno are probably the most used ones at the moment. Also, if you're using commercial container orchestration security suites, they should all have something which does that. There's a Kubench, again, another Aqua one, but it's another completely open source project that will do the CIS Kubernetes benchmark. So essentially, again, if you're a pen tester or an auditor, it's a good place to start because you can run that against a cluster and get an idea of some of the basic things which are wrong. It won't do everything for you, but it's kind of a good starting point. So one or two, just before I kind of like finish up, I think I'm looking for time. Not too bad, I don't think. One or two, just some gotchas that I think come as a surprise to people when they get involved with Kubernetes security. The The first thing is if you're doing on-premises Kubernetes, none of the authentication mechanisms that come with Kubernetes as by default, so just as a straight open source project or some of the kind of more vanilla distributions, none of them are suitable for production use. You have to get an external authentication service to run with the cluster. The options you have at the moment within the product are token-based authentication, which is a clear text token held in a file on the API server, which is obviously not going to be suitable for authentication, or client certificate authentication. That might sound like it's okay, but extremely importantly, there is no support for revocation of client certificates. There's an open GitHub issue, if anyone wants to go and comment on it. It's been open for about 6 years now. So if you use client certificate authentication and then the person with the client certificate leaves the company or moves team and you want to change their rights, or they lose their laptop, or someone compromises the home directory in their laptop, you have to revoke the entire certificate authority for the whole cluster in order to get rid of that certificate. There's no way to revoke it. So important point, do not use client certificate authentication in Kubernetes. Another one which will trip you up, especially if you are reviewing existing clusters, Kubernetes does not have a user database. If you look at all the objects that a cluster has got and you say, show me a list of users, it can't. It doesn't have one. Essentially, what it does is it relies on the external authentication service to tell it the username, and then it looks up its authorization system and says, what does that username have rights to? But it doesn't have it internally. So it means you need to work with some whatever external services it's got and work out what users have got what rights. And one that's kind of again could come as a bit of a surprise is there's a hard-coded group called System Masters. And System Masters is hard-coded in the API server source code. Any member of that group will have cluster admin rights, even if you remove every single RBAC entry in the entire cluster. They will still have cluster admin. The reason I mentioned that specifically in conjunction with client certificates is that some Kubernetes distributions, in fact, quite a few of them, will start the cluster off with a client certificate that is a member of System Masters. That means it's an irrevocable backdoor into the cluster. You can't get rid of that access without changing the certificate authority. So it's very, very important to make sure that that file is handled well. That essentially it's locked away somewhere and kept offline and only used for break class purposes. That's not necessarily all that well known, so definitely want to watch over. When I was pen testing, I would not uncommonly be handed that certificate to do my test, and I had to say, you've just given me something that you can't revoke. Obviously, I will get rid of it at the end of the thing, but whatever procedures you need to do to manage that. The other one that I think is coming as a surprise to enterprises that are getting heavily into Kubernetes is that the support lifecycle is very open source, if I put it that way. It was 9 months up until, I think, the last release. It's now gone to 12 months. So you only get 12 months of support, including security patches, from your Kubernetes cluster. That means you have to be ready to upgrade the entire cluster every year. The cloud providers will probably give you a bit more, but not a lot more. And if you're using cloud-managed Kubernetes, so EKS, AKS, GKE, it's still your responsibility as a cluster operator to upgrade your worker nodes. They won't do that for you by default, partially because if they do, it might break things. The reason I mention this specifically is I've been started tracking intranet exposed clusters. They actually expose an endpoint that lets you tell what version they are. And I think definitely over 30% of EKS clusters, so Amazon's managed Kubernetes service, are running unsupported versions of Kubernetes, which obviously is a big problem if there is a CVE that comes out in the API server. That means they're going to have to rush upgrade, a whole lot of intranet exposed clusters. So I definitely would watch for that if you're looking at rolling out Kubernetes. Is that lifecycle thing I think is catching quite a lot of companies out. And in terms of like generally securing Kubernetes containerized environments, there's a couple of things to think about, I think, in terms of how it's a bit of a different mindset. Workloads are ephemeral. You don't patch running containers. That's an anti-patcher. You should never, ever patch a running container. In fact, you generally, apart from troubleshooting, never really shell into or log into a running container. What you do to manage patches in a containerized environment is you patch the image, which you've got in your own container registry, and then you redeploy a new instance of the container with the patches applied to it. So you don't ever patch a running container. And credentials have to be held outside workloads. You never ever put secrets inside container images because they're held in a public registry, or even if it's a private registry, you've still got too much access to it for secrets. You need to hold those in a dedicated secrets management solution, either using Kubernetes or using your cloud secrets management system, but you need something that's not the kind of usual way you would do it. From a kind of advantages point of view, as a security person, one of the things I like about cloud native and kind of containers is everything is code. So all of your Kubernetes manifests are code, all of your Docker files are code. If you're using Terraform then and Ansible, all of your deployment logic is code as well. So it does let you use things like infrastructure as code scanning to actually review things early on in the life cycle. So things like Trivy, I'll use that as an example because we just added IAC scanning to the open source project, which means you can give it to developers and say, scan your Docker files, scan your Kubernetes manifests before you give them to someone to deploy. That way you've got a good idea that you've fixed the issues before it gets further on and actually into deployment. So conclusion, just to bring all that together. So containerization makes very heavy use of existing technologies. Fundamentally, Docker is Linux. Everything Docker does is Linux. Kubernetes is basically a set of REST APIs managing Docker or managing something like Docker, but that's pretty much what it is. So a lot of existing security techniques can be reused. If you're used to doing things on Linux, then you can apply a lot of that to Docker. I haven't really talked about Windows containers; they are a bit different, but most of the container world at the moment is still Linux. You do need some new approaches though. So things like recognizing things that are ephemeral, that container workloads go away. That impacts not just patching, but things like forensics and logging and monitoring. So obviously, if I've got a container that can be moved from one node to another in a cluster within an hour, I can't just rely on the logs from that container. I have to in some way, map the logs back to other instances of that container. And then there's definite gotchas. So what I would say about both Docker and Kubernetes is they were not, this is my personal opinion, they weren't designed with a kind of a security first mindset. They've actually made good steps in like improving their security as they get more popular, but the starting point was ease of use. It was about giving people the ability to deploy and write applications and get them running quickly and easily. So as a result, there's going to be some kind of rough edges, things that perhaps from a security perspective aren't ideal and definitely worth keeping an eye on. Questions? Questions now if anyone would like to ask questions, or there is my Twitter handle and email.
Great, Rory. Thank you very much for this exciting presentation. I must say I found it really interesting, just as a continuation of your previous container talk on actually seeing, as you said, this bunch of REST APIs working together, and it's not built in, like security is not built in both for container and for Kubernetes. Found it really helpful. So thank you very much for sharing that. There's a couple of questions, yes, from the audience. Let's just start with one on Slido because there's been asked first. Sure. So there is one question about whether container runtime environments have the same problem as Docker or work the same way. For example, Containerd.
Yeah, so essentially it depends a little bit on the environment. Containerd essentially is identical to Docker. It's actually running underneath every Docker install. So when you get Docker, it's actually 3 projects, runc, Containerd, and Docker that are being used. So yeah, Containerd essentially has the exact same problem. Cryo is similar because Cryo works very similarly to Docker and Containerd. There are some other ones which work differently, and that's got pros and cons. So gvisor, which is a Google project, and that creates an actual sandbox, like a specifically designed security sandbox on top of Linux, and that obviously doesn't have some of the same problems. It also isn't quite as flexible, so it might not work in every use case, but gvisor is well worth a look if you need a bit more isolation than you get out of Docker. There's also projects like AWS Firecracker, and Firecracker essentially, their approach, which Amazon use in some of their commercial products, is to create a lightweight virtual machine. So their goal is to try and create something which uses virtualization technology, but runs like a container. And you can actually run it underneath like Kubernetes, and it'll work the same way, but it's actually a VM.
Excellent. Thank you very much. And there's also another question around other tools like SE Linux and AppArmor. And the person is asking whether those tools help at all in regards to securing Dockers, like an SE Linux config that can monitor Docker directories.
Yes, is a short answer. It's worth noting that whilst Docker can use AppArmor and SE Linux, And with AppArmor, they have a default profile. So if you run a Docker container, it will apply an AppArmor profile. The same is not true of SE Linux. So you have to come up with your own. Now, anyone who's done SE Linux knows that can be tricky depending on how. But yes, it is absolutely possible. And it's definitely well worth a look if you want to kind of like harden down that attack surface. One other thing to mention, actually, which I didn't mention in the talk, is there's a seccomp filter, seccomp being like kind of a syscall filter that Docker have as well. Very importantly, Kubernetes turn that off. So if you're using Docker underneath Kubernetes, it turns off the seccomp filter by default, and you have to go and turn it back on again. So yeah, essentially you can add layers to it to try and lock it down a bit more, and AppArmor or SE Linux would go on.
Great, thank you. And there's also another question from the audience about, given the fact there have been POCs for bridging a VM barrier, as for example, escaping the guest OS and entering the host, perhaps with an LPE. What is this regarding about containers?
Yeah, so what I would say is, it's a good point that it's not black and white. So people kind of say, you know, are containers insecure, are VMs secure? It's not that black and white. I think that VMs have had breakouts, sandboxes have had breakouts, and Docker's had breakouts. It's just a question of how big the attack surface is. And what I would say is that Docker's attack surface is fundamentally larger because it's the entire Linux kernel. That's the problem. VMs can be kind of designed to try and limit. So for example, Firecracker, they've got rid of a lot of the devices, the virtual devices that caused a lot of problems for other VM solutions. And there have been quite a few escapes from Docker containers. The most recent of which, and this is an illustration of a problem in containers, it happened in the runC project. So the runC project is a different project, but it's used by Docker. You needed to be quite careful to monitor the CVEs coming out from runC and Containerd and Docker, because it took Docker like 5 weeks to patch. So if you didn't know that was there, you know, you could leave yourself with an open window for 5 weeks, unless you're happy monitoring runC, which most people don't even know when they install Docker that they're actually using runC, because it's hidden away under the covers. What I would say, basically, is my feeling at the moment is that Docker provides an isolation, but it's a bigger attack surface, and it's quite a lot bigger. So we're going to see more breakouts there than you would in like a sandbox or a VM.
Excellent, thank you. And there's also another question about using Falco, the Falco project for cloud native runtime security. What is your thoughts on that? So
I think that, Falco has been a good project, and I've used that again in the previous life as well. I think that projects like Falco are good for getting that runtime security. So monitoring what Falco is, there's things like Falco, Tracy, and a couple of other projects that essentially what the idea is that you can review operations inside a container as they happen, and the kind of cool new way of doing that is using eBPF, which is a technology that embeds itself into the Linux kernel to try and monitor everything that's happening. And they're good for that kind of runtime security view. So I can get one of these projects and I can say, okay, what's happening in my container? I'm looking for bad things. And it's kind of easier because it is all Linux, right? So as long as your kind of runtime security solution understands Linux, it can probably work with containers.
Excellent. Thank you very much. There's also another question, actually from my side, more looking at being one of the co-authors of the CIS benchmark for Container and Kubernetes. What would you say are the three major hardening guidelines you would advise for people who are just getting started with containers and Kubernetes?
Yeah. So if you are, I was going to pick three. If you are writing containers, you're making container images, you're a developer, don't run as root. Add a user, do not run as root. That's the big one, because if you don't run as root, it becomes a lot harder. Essentially your process is now just a standard user process. So there's that extra barrier to break out. If you're running Docker, it's primarily not giving access to the Docker socket. So if you're running other people's container images, don't let them access the Docker socket, because that's root. Don't run privileged. If you see a third-party app that says, hey, I want to be privileged, be extremely careful that you know what that's going to do. In Kubernetes, I think the main thing for me has been when I was pen testing container orchestration solutions, the ones I had the least fun with as a pen tester were the ones where they didn't give people direct access to the Kubernetes API. They essentially forced people through some kind of pipeline, said, look, you give your app to the CI/CD pipeline, it goes through the pipeline, and then it's deployed. We've got checks and we've got gates along that process, which will validate and check to make sure what's being run. When you give people direct access to the Kubernetes API, RBAC's just quite tricky, and it's really easy to make mistakes. So not you can't do it, it's just you have to be super careful. To get rid of that, don't give people access to the API. Just let them go via CI/CD.
Excellent, thank you. Yeah, and I just have to totally agree with that. This basically RBAC is key for that, and just locking down access. Great, thank you. Are there any more questions from the audience? Oh yeah, so there's another one. Is there any good practices to put additional IP table rules, persistent ones, on top of the ones which installs Kubernetes during runtime?
If you can possibly avoid it, don't put IP tables rules on container host nodes. I'll tell you why. Both Docker and Kubernetes make extensive use of IP tables for their networking. So when you do things like Kubernetes services, Kubernetes service is a kind of a virtual object, and it's actually an IP tables rule. If you do Docker and you're doing port forwarding, that's actually IP tables rules. And people have come a cropper by not realizing that Docker, unless you tell Docker not to, it will go and modify your IP tables rules for you. So typically I would say, because it gets quite complex, and if you look at a cluster, the IP tables rules are massive. There's hundreds of lines of trying to get that right and avoid, and trying to make sure your rules don't interact badly with their rules. I would try and avoid it. I would try and do off-host firewalling. So do it at network boundary or do it somewhere else, not on the cluster. Just because I've seen, if you ever try, go into a Kubernetes cluster node and do IP tables, man, it's hell. And you get a nasty shock when you realize all this fancy software-defined networking is just IP tables.
Great, thank you very much. Is there any other questions from the audience? What container or orchestration security, Kubernetes, or maybe Scottish Highlands? So basically, Dirk is saying yes, he knows, but he was thinking of raw rules which we processed before.
Yeah, I think theoretically possible, but I've never seen anyone do it. Put it that way. I've never seen anyone actually try. And when I look at it, I go, it would be super easy to either break the cluster, to do something which interferes with the cluster, or to have it bypassed by some later rule. So yeah, in theory, yes. In practice, you'd want to be quite careful.
Okay, excellent. Thank you very much for the great presentation. And again, all the slides are going to be made available and will be published to YouTube. And yeah, really delighted just to share your insights on containers as well as Kubernetes. So I think it's a vast topic. It's very difficult to understand, and really delighted to have you here.